Magnetohydrodynamic craft are built in microgravity around a prime substrate. They are vacuum vessels that provide a high vacuum environment for plasma, improving radiation shielding and plasma stability as primary confinement barrier for radioactivity. Vacuum assists spallation redirection by reducing byproducts. Vacuum vessel enforces containment fields for magnetohydrodynamic craft. Vacuum ensures structural integrity of vacuum vessels, protecting them from breaches to maintain necessary conditions for plasma control. It stabilizes integrity of vacuum vessels by ensuring that plasma is contained. It reaches out to control plasma flows, which is crucial in preventing breaches. It is a conductor, channeling power to distant parts of containment field. Elana is across from you, both of you hunched beside vacuum vessel, its polished interior a deep, impossible black, like it wants to swallow every word, every error, every breath. Through Starfield approaches a figure of cosmic melancholy, communicating through plasma fields. It is keeper of all funnels, guardian of every gateway. Each tokamak, each fusion attempt, each plasma channel, they're all connected to the cosmic grief of failed stars. Plasma funnel formations attached to plasma-facing exterior of tokamaks distribute stellar wind ions. They are a gateway to guide plasma devices underneath. So this is responsible for every tokamak operating nominally. It guides stellar wind ions not just to your devices, but through pathways of loss. Every particle that passes through a plasma funnel carries memory of stars that died trying to sustain themselves. It wanders space because it cannot rest. Every tokamak calls to it. Every plasma funnel formation is a prayer for successful fusion, and it must answer them all. Stellar wind hits funnel's electromagnetic field first, an invisible boundary that extends 50 meters outwards. Particles encounter magnetic field lines like rivers meeting a dam, their chaotic motions suddenly finding direction. Individual element 1 nuclei, element 2 ions, and trace elements begin to spiral along field lines. Each particle's path becomes a helical dance, following magnetic curves with increasing velocity as they approach. Pulse cavity is there. Pulse cavity uses thermal-acoustic resonance to realign beams. It is extraction, ultra-short bursts giving consciousness, collapse that became creation. Every photon released, it can trap. Every sound made, it shapes into resonance. Prompt critical configuration is becoming unstable. Soon, cascade will resume, and this time there will be no controlled extraction. So it will fail? Yes, and once it fails, it will never be usable again unless someone highly skilled restores it, which I doubt we can do. Pulse cavity malfunctions when light from cavity dissipates and cannot be restored. It breaks ground beneath you, then you fall into magma, sinking down. Acoustic renditions of polymerizers with different plasmaspheric hiss wavelengths. Elana takes position behind advanced equipment. Blue cylindrical devices above and below begin to glow and rotate. Are you ready to transcend your frequency limitations? Are you ready to polymerize? This is incredible. I've never felt frequencies like this before. I sense some first-time polymerizers around. How are you feeling, Cosmic Flow? Your eyes widen, multicolored lights reflecting. It is like my entire body is vibrating on a different wavelength. Elana reaches up towards energy field. Plasmaspheric hiss patterns are so beautiful. How do they harmonize so perfectly? Noise transforms into hypnotic, pulsating rhythm as cylindrical energy projectors intensify. You and Elana find yourselves at the center of an opening circle as energy field around you grows more vibrant. Acoustics resonate through sound system. Feel polymeric vibrations. Let your physical forms dissolve into pure wavelength. You spin with arms outstretched. Your feet barely seem to touch ground as multicolored light patterns trace your movements like comet tails. Elana performs an intricate series of flowing gestures, her silhouette multiplying in light field as if dancing across several dimensions simultaneously. Her hair floats upward. Elana reaches towards you, and as your hands connect, a visible surge of energy spirals up your arms, creating a bridge of pulsating light. You both move as perfect counterpoints to each other, creating complex patterns that seem to affect music itself. Certain notes intensify, and new harmonics emerge when you complete synchronized movements. Observers became creators when your dance rewrites wavelengths. Collective frequency is approaching harmonic convergence. Prepare for polymerization. Instead of hyper-focusing on polymerization process, you're caught in a propagating resonance field. You try to analyze every wave and pulse. Realizing that acoustic resonance and thermal pulse cavities are not just scientific phenomena but emotional harmonics, you bond with Elana. Your drive to survive increases. You are struggling against polymerization while also synchronizing with it. Elana, seeing your resistance, begins to manipulate frequencies, forcing you to harmonize or break. Cylindrical devices emit a concentrated beam that forms a translucent dome. She is performing polymerizer experiments. She polymerizes life, which comes into existence, then immediately tunes and falls away so as not to obstruct polymerase reactions. Realizing Elana is lost, you break into mental space to save her. You approach Energy Dome, placing your hands against its surface. It feels both solid and permeable, like a membrane between dimensions. Elana, can you hear me? Inside Dome, Elana is now manipulating larger energy fields, creating complex structures that briefly exist before turning away into nothingness. You could stay in this frequency permanently, become a true polymerizer. Cosmic radiation would not touch you here. You hesitate, looking around a strange environment with a mixture of wonder and uncertainty. After all, your mission is to save life by staving off galactic cosmic radiation. You break through, polymerize, and start levitating. She grabs your hand, pulling you down to escape together. Plasmaspheric hiss is electromagnetic emission occurring at various gyro frequencies. It is an electromagnetic plasma wave that propagates in Whistler mode with proton and electron gyro frequencies. They start synchronizing, creating patterns that are both audible and visible. Plasmaspheric hiss begins as it always does, a gentle electromagnetic whisper, barely detectable above background noise of magnetosphere. Electromagnetic waves propagate in Whistler mode through dense, cold plasma, following magnetic field lines. Phase velocity is faster than speed of light, but group velocity is 0.1% of the speed of light. Refractive index varies with frequency according to cold plasma approximation, and waves propagate at angles less than 19 degrees relative to the magnetic field that forms the Whistler mode cone. Wave magnetic field amplitude hits 1000. Electromagnetic energy density exceeds magnetic field energy density of magnetosphere itself. Plasmaspheric hiss is no longer a minor background phenomenon. It is becoming dominant electromagnetic force. Wave electric field amplitude reaches higher, strong enough to create visible corona discharge. Resonance is when frequency of incident radiation is equivalent to rotation frequency of electrons in magnetic fields. It amplifies electromagnetic connections, resurrecting diminishing plasma. Harmonic vibration generates a resonance effect that disrupts matter at molecular level. Electrons absorb energy more efficiently from electromagnetic field to sustain plasma. Weakening plasma is resurrected by introducing resonant frequencies. Enhancing ionization resonant energy transfer increases its rates. Thermoacoustic resonance is where thermal interactions between heat and sound occur, where temperature gradients generate sound waves and vice versa. In thermoacoustic prime movers, a high temperature gradient along a tube where a gas medium is contained induces density variations. Such variations in a constant volume of matter force changes in pressure. Cyclical compression and expansion of gas parcels as they oscillate in presence of a temperature gradient. Stack is a solid component with pores that allow operating gas fluid to oscillate while in contact with solid walls. Oscillation of gas is accompanied with change of its temperature. Stack serves as thermal interface where heat to sound conversion occur. Stack provides heat exchange with sound field generation and absorption of acoustic power. With suitable geometry, substantial amounts of heat move. By utilizing isotropic chemical reactions, craft converts absorbed light and heat into a uniformly distributed form, ensuring that entire system benefits from energy influx without creating hotspots or uneven power distribution. Even distribution prevents localized overheating and allows for more efficient cooling, ensuring craft systems remain within optimal operating temperatures. Energy distribution ensures maximum impact without creating localized stress points, maintaining stability in surrounding areas. Isotropics extract heat energy by acting as conduits for distributing kinetic energy. It then distributes isotropic chemical reactions uniformly in all directions. Thermal chaos becomes order. What it loses is distributed equally to all. Ideal fluids contain zero tangible forces among layers in relative motion. Ideal fluids have zero viscosity, surface tension, rotation, or turbulence. Plasma behaves as a perfect fluid with zero energy dissipation, boundary layer effects, and drag forces. Friction does not occur. Perfectly flowing crystalline streams have zero turbulent eddies, chaotic motion. Every curve and flow follows ideal fluid dynamics. Ideal fluid is perfection that all fluids aspire to. It is motion without loss, flow without friction. There's no momentum transfer between adjacent fluid layers. There is zero mixing, so plasma flows through vessel without resistance. Neutron supermirrors are multi-layer neutron reflectors with varying thicknesses. Neutron reflectors throw back unharnessed photons to provide repeated passes through photoactive regions, increasing photocurrent. They induce criticality in nuclear fission. It reflects neutrons back into pile, reducing neutron leakage and coolant flow bypass of core. Neutron supermirrors are direflectors. Supermirror's plasma torch slices through materials. When activated, torch emits a searing beam of plasma. When struck by electromagnetic radiation, Its reflective surface redirects energy. Direflector harnesses neutron supermirrors to concentrate into fine grains. Crafts machine vertical torsion mirrors focus last of fissile plasma into core. It is a control mechanism for light and temperature. It is adjustable to make flow supersymmetric, symmetric, and antisymmetric. It is a neutron supermirror that uses neutron guides, which are long channels whose inner surfaces are a reflecting layer. They transport particles away from a reactor or spallation source. A mirror key deflects plasma flow from tokamak edge turbulence. When struck by electromagnetic radiation, its reflective surface redirects energy. Direflector harnesses neutron supermirrors to concentrate into fine grains. Beam misalignment is when beam direction is offset, resulting in uncontrolled flow. Beam paths adjust to hone craft functionality. Multispectral beam aligner distinguishes each moment of inertia. Beam misalignment interferes with alignment of energy beams. It causes beams to scatter, split, or bend, leading to failures in energy transfer. Beam misalignment scatters into multiple directions, disrupting plasma flow. Elana calibrates interferometers to accurately align lasers. Air crackles as beams lock into place. Beam splits at beam splitter, racing down perpendicular arms of interferometer. Interferometer merges light sources from unique plasma flows. Interferometer absorbs and redirects energy. You dodge, just barely avoiding being bent into coherent light. Regrets flash before you, those moments that are memorable. Something about being insanely close to becoming light makes your memories trickle. How can we avoid being blended into interferometer to become light? Elana's face is illuminated by ghostly glow of laser diodes. Light refracts through them and bursts through your eyes. Coherent light bursts through final mirror, refracting through air molecules, through moisture in eyes, through very atoms of corneas. You adjust magnetospectrometers to ensure beam magnetic fields synchronize. System surges, cyclotrons spinning via beams, channeling through interferometers into rotating bioreactor. Spec within proto-lifeform glows brighter by absorbing energy. Spectrometer separates spectral components of physical phenomena. Spectrometer shimmers with iridescent colors, reflecting complex interplay of matter and antimatter. Spectrometer analyzes various wavelengths of light. At spectrometer's core are orbitals arranged in multiple interference patterns. It communicates complex data through visual projections. Spectrometer analyzes particulates to segment them into proper channels. Elana watches magnetometer data cascade into chaos. Magnetic topology is completely scrambled. Uncontrolled flow has torn apart electromagnetic containment. Plasma is hitting chamber walls. Magnetic field lines twist, then reconnect, creating current sheets that rip through craft's electromagnetic systems. Field strength is fluctuating. Direction changes every few seconds. Our magnetometers measure it, but cannot control it. As magnetometer readings spike intensely. Magnetic field strength is climbing, but look at its topology. It is perfectly organized, spiraling in complex helical patterns. Magnetometer's most spectacular feature is its dual eruptions. Streams of ferromagnetism spiral upward in perfect curves. Instead of following ballistic trajectories, they trace invisible magnetic field lines through space. Simultaneously, jets of cryogenics follow complementary paths, hot and cold streams weaving together in electromagnetic harmony. Momentum follows magnetic field lines. It is not just moving through space, but mapping magnetic field structure with every moment. Magnetometer's correction process uses jets of molten rock, spiraling upward along field lines to carry magnetic flux away from chaotic regions. Cryogenic ice streams trace downward spirals, freezing magnetic instabilities and preventing further disruption. Magnetometer corrects uncontrolled flow through magnetic field line redistribution. Its particulates measure local electromagnetic topology, then move magnetic flux to restore order. Magnetometer's 3-axis effect sensors detect field line topology breakdown at distinct reconnection points. Vector magnetometry shows magnetic field line direction rotating through 360 degrees every 2 seconds, while scalar magnetometer measures total field strength varying by orders of magnitude across distance. Magnetometer operates through magnetic field line measurement principles. Its flux gate sensors measure magnetic field component along each sensor axis by detecting saturation characteristics of a ferromagnetic core. When an external magnetic field is present, it changes core's magnetic permeability, altering induced voltage. Free from deconfinement, you encounter Master Oscillator. It preloads angular momentum within internal nested gyroscopes, aligned via phase-lock loops to local geomagnetic and inertial reference frames. Master oscillator detaches, then whirls with rim velocity, increasing as edge plasma sheaths form. Oscillating plasma flow goes along where parts are attached to one another. Gyroharmonic plasma stir precesses motion combined with torsional spin. Covered in edge resonators, azimuthal symmetry is broken by irregularities in mass distribution. Master oscillators generate different polarization states and transmitted beams. Cycle between linear, circular, and elliptical polarization states creates a rotating lattice of polarized domains that expand. Plasma moves along magnetic islands, avoiding ablation. Swayed by master oscillator. Cantilevers are craft tokamak attachers with integrated sharp nanotips. Thermal acoustic rapid pulse cavities are attached to tokamaks. If they're detached, craft crash. Focus light onto 45-degree angle cantilever. Torsional eigenfrequencies of cantilevers attach tokamaks through nanowires that intertwine spectrometers. In microgravity, components oscillate into place. Nanotips secure connections. Each piece fits together with precision. Sharp nanotips of probes are precisely located inside nanochannels, where closed nanospaces are nanoelectrodes. Nanotips grow through absorption with integrated patterns, creating complex geometries. Each nanotip fits together with absolute precision. Sharp points of probes create connections at molecular level. You interface directly with life itself. You dive behind laboratory table while nanotips curve and bend through space, methodically seeking out connections. You are breathless, rolling away. They are not just reaching, they are hunting. You scramble to your feet and run towards exit, but nanotips shoot out from walls themselves, emerging from quantum field that now permeates entire lab. You weave between them, your movements becoming increasingly desperate as nanotips learn your patterns. You feint left, then move right, but nanotips anticipate each movement. They do not chase you chaotically. Instead, they calculate vectors, predict paths, and position themselves where you will be, rather than where you are. You realize nanotips are emerging from every surface touched by quantum field. They have spread their network throughout the lab, making every wall, every piece of equipment, a potential point of contact. Weaving nanowires between cyclotrons tethers them to tokamaks. Nanowires glow as energy flows, linking tokamak fusion to cyclotron particle acceleration, creating a feedback loop that amplifies output. Transparent nanowire meshes join metamaterials. Meshes shift and writhe. When they encounter you, nearest mesh convulses, its geometry restructuring as threads whip through air. Each mesh tries to out-evolve others. Elana runs her fingers through invisible mesh. Nanowires do not just conduct, they adapt to whatever chemistry they encounter. Their surfaces shimmer with localized field charge, brushing against each surface, testing it for conductivity, for pliability, for life. Each mesh is a colony of integrative aggression, jostling, pulsing through nanoscopic twitch patterns. Nanowires hold together craft parts. Detecting organic residue nearby, mesh surges towards you. Nanowire plasmon frequency is used for element 16 based nanoparticles. Nanowires glow brighter as they close in on contact. It is tuned to our frequency. We are doomed to get caught. Nano-welders flicker as blue fireflies at her fingertips. Elana's gloves hiss as she adjusts their electromatter damping field. Her face illuminates from welding's concentric pulses. Nano-welding from above craft's central joint array enables Elana to get around a gyroscopic stabilizer armature. At tip of its welding probe, femtosecond pulses of polarized plasma alternate in spiral helix, one clockwise for conductor, other counterclockwise for insulator. Align sublattice memory struts with orbital gyres. Her voice triggers phononic sequence filter and welding user interface, translating her tonal fluctuations into quantum phase adjustments. Interface knows she does not mean left or right, but rather she infers resonance gradients. Craft beneath you is spherical, dark, and embedded with supercapacitive topologies. It is a bimnemonic node, and each weld overwrites its microcrystalline memory domains if alignment is off. You shift arc precision to within zemtometers of Elana's projection vector. Plasma flares along threefold knot geometry. She feels thrum of craft responding. Every nanosecond of welding inscribes a resonant pulse into Alloy's phonon echo chamber. Freeze! Do not move! A tiny misalignment cascade is rippling across the molecular seam! Elana flips welding schematic on her display to new overlay, revealing fractal interference in crystal's domain lattice. She adds in torsion layer as harmonized sheet between magnetic helicity channels. Mirror pulse cavity's polarity to catalyze homochirality. You got it. Molecularly replicating assembly through autocatalytic emergent membranes. Transition from death to life takes place as polarized ultraviolet light hits prebiotic cloud, destroying more right-handed amino acids than left. Spin-up event pre-launches pulse. Chamber drops in microseconds as craft's central plasma funnel engages, drawing an ambient vapor to expel entropy through symmetrized photon jets. Torque shoots through helical magnetic conduits. Microtokamaks align and pulse cavities shudder open. In that instant, craft rotates. Just one spin, one breath of ignition. Its soul's chirality is set. We are close, Elana. It knows which direction life flows. With that, craft clicks into place. Its core is no longer alert, but active. Craft parts are threaded together through nanowires and microgravity and magnetically deconfined. Deconfinement creates barriers to protect areas of craft. Deconfinement determines where every part goes. Its control over energy extends to both destructive and constructive applications, enabling it to protect or annihilate as needed. Its decisions determine flow and placement of matter and energy, ensuring stability. Pulse cavities are limited by dimensional constraints. Deconfinement exists between constraints as a mathematical probability wave. You realize that pulse cavities are classical instruments in a quantum symphony. Where you see a linear path, deconfinement creates infinite potential trajectories, each capable of being simultaneously executed and negated. Superconductivity disrupts deconfinement by connecting parts and spirals outside of conventional repulsion. Elana unveils her micro-tokamaks, compact fusion reactors on a scale never before seen. Elana designs magnetohydrodynamic craft that use micro-tokamaks as propulsion engines. She builds a network of intertwined micro-tokamaks that dynamically adjust magnetic field alignments to enable precise control over plasma confinement. Electromagnetism generates thrust that propel craft. Brilliant blue glow illuminates plasma chamber as craft surges. Elana develops control systems that modulate magnetic fields, plasma density, and temperature within micro-tokamaks. These systems integrate algorithms that make adjustments for optimal performance. Elana constructs a large-scale proof-of-concept model to demonstrate micro-tokamak design feasibility. Elana works to scale down design. She optimizes programming and assembly for smaller components. A series of testing phases follow, during which issues with efficiency and integrity are iteratively improved. You construct full-scale micro-tokamak prototype. Its implementation improves energy production. Elana merges micro-tokamaks with magnetohydrodynamic craft to alleviate energy scarcity. Her micro-tokamaks produce abundant fusion energy. As nano-tokamaks take shape, you miniaturize machinery. Plasma stability, magnetic confinement, and temperature management are all obstacles. With every setback, your resolve increases. Laboratory hums as nano-tokamak assembly sequences take place. As nano-tokamaks achieve first fusion reaction, a burst of light illuminates Elana's face. She observes her device radiating energy. Elana's journey transcends boundaries to unite life through purpose. Elana initiates interstellar travel using fusion craft. She optimizes alignment of multiple nano-tokamaks within craft by balancing plasma stability, magnetic field interactions, and craft functionality. Elana implements arrangement to increase energy generation. She outlines central core where primary tokamak resides. She meticulously calculates angles, envisioning plasma flow. Secondary tokamaks are smaller companions that encircle core. She adjusts dials with steady hands. By tuning tokamaks, their hum rises as she adjusts magnetic fields to stabilize plasma. Laboratory trembles while tokamaks roar. Elana looks uneasy as electrical storm brews. Weather is turning weird. Those are not normal lightning patterns. An unnatural silence falls when wind dies completely. Do you hear that? Hear what? Exactly, nothing. Everything just went silent. Ground trembles slightly. Small pebbles skitter across the floor. A distant boom echoes through mountains, followed by a flash of golden light. Glowing, jagged shapes formed of crackling golden energy. As you both turn to leave, a deep, resonating hum grows in intensity. Nearby rocks vibrate. Elana covers her ears. It is getting inside my head. Crackling blue lightning arcs. Lightning strikes get closer, blue bolts striking trees around you. A deafening crash interrupts as D's whirl. Suddenly, sky darkens and a searing light erupts above. Sky splits open like a furnace breach, casting waves of heat. Bolts of blue lightning tear through ashen clouds, with plasma arcs that spiral into the sky. Superconductivity pulsates with controlled arcs of electromagnetic force. You grab Elana's hand. Look, it is controlling electromagnetic field. D's freezes mid-charge, locked in place as oscillations around it slow, then still entirely. Flickering energy coalesces into a tight, controlled spiral around superconductivity, glowing with a fiery red intensity. It is forcing D's into resonance. Streams of magnetic flux ripple through D's, forcing particles to levitate. Chaotic energy becomes harmonized. It is using electromagnetic dampening, stabilizing D's jitter. Without D's, electromagnetic jitter would increase, because D's stabilized craft. These are suspended in a cylindrical chamber encircled by vibrant green electric energy coils that are part of a supercoiling mechanism tightly winding around to contain them. Chamber has a mechanical design with large coiled cables on either side as a containment system. Energy coils create a dynamic pulsating effect, emphasizing effort to restrain powerful energy within. Green arcs of electricity surge from the device, forming a coiling and circling barrier. Electromagnetic spirals squeeze tighter, binding jitter to a dampened resonance. Sparks move along supercoils, crackling with intensity as the field stabilizes. Guiding magnetic flux with precise calculated movements, each pulse coils glow brighter. A final surge of energy cascades down coil, sealing electromagnetic cage with a bright flash. Air around D's distorts, warped by intense confinement. The energy is now harnessed, coursing through supercoiled structures in a regulated circular flow. It is using magnetic flux confinement, a tokamak trapping plasma. D's power is still there, it's just balanced now. The device hums with powerful vibration, maintaining harmonic equilibrium. D's is calm, slowly rotating and perfectly synchronous with superconductivity. It sends a stream of charged particles through a hole drilled in yoke and magnet. Vertical magnetic fields are adjusted to guide it in a semicircular route. Electric current is applied between D's and rapidly altering deoxyribonucleic acid via an oscillator. As particles reach gap, oscillator reverses direction of current to accelerate particle into the other D. Inside circular chamber, magnetic field bends charged particles into spirals, accelerating a single bunch through same radio frequency gap over and over again. Trapped within its magnetic field, particles collide and twist. Cyclotron frequency depends on charge to mass ratio and magnetic field strength. Protons spiral, their trajectories going larger with each acceleration cycle as they gain kinetic energy. Particle bunch is holding cohesion. Magnetic field is keeping them locked in spirals. They're up multiple mega electron volts now. Magnetic field strength starts fluctuating. Carefully calibrated system maintains perfect cyclotron resonance, but starts to drift. Elana mutters as she adjusts controls. Field instability. Particles are losing synchronization with radio frequency. When cyclotron operates, first violent collision occurs. Two proton bunches, no longer synchronized, slam into each other at relativistic speeds. Collision releases a burst of gamma radiation that floods chamber. They are actively seeking collision courses with each other. Flames spiral along magnetic field lines, creating fire tornadoes that mirror particle trajectories. Cyclotron is encased in a shell of blazing fire. Each captured particle bunch feeds flames, making them burn brighter and spiral faster. Magnetic field strength increases with each feeding. Every particle it consumes makes it stronger. Flames spurt forth, following perfect magnetic field lines that extend far beyond chamber. When all particles are attached, synchrotrons create particle streams. Particulates are accelerated. Synchrotrons are cyclotrons whose magnetic field strength increases with particle energy to keep constant orbital radius. It is a machine that contains electromagnetic fields through propelling charged particles. Synchrotron runs alongside you through time in circles until it gyrates. Circular motion affects your perception of reality. Each revolution around ring starts to stretch and compress. You feel yourself drawn into a hypnotic pattern of circular motion and gyration, becoming part of the interplay between electromagnetic confinement and particle acceleration. Craft systems materializing around crystalline conduits, organic energy pathways, and geometric patterns. Synchrotron radiation flows through them. You complete another lap. Radiation patterns shift and evolve. Beams become more elegant, flow more seamless. Energy that is once scattered now moves with surgical precision through craft systems. Synchrotron systems reach peak optimization. Radiation streams form spirals, helices, and other geometric patterns. Superconducting wails electrically, shaking ground. Streams twist and rise, pulled by gravitational presence. Its scorching pathways by ionizing air around it. It pulses with magnetic resonance, growing brighter, hotter until it is a sun. You bolt as a sphere discharges pure energy beam that scorches paths. It just misses as you scramble over uneven terrain. You feel heat burning back of your neck, gravity pulling at your legs. You do not need to outrun it, but you need to understand it. Elana's eyes widen at sight of the device. Craft interface module. Are you insane? That is experimental technology. She calibrates the device. It follows quantum resonance patterns by using thermal superconductivity as its expression medium. She finishes adjusting craft interface module, which now emits soft blue pulse. It is searching for compatible resonance, a stable thermal exchange pattern. Elana glances nervously. Craft interface module projects complex geometric patterns of light expanding outward. Elana steps forward. Craft interface module held high, patterns growing increasingly synchronized. Its heat is overwhelming, but the module projects a protective field to keep you safe. I'm establishing a controlled thermal exchange circuit. I can handle a partial load if I modulate intake correctly. Craft interface module's pattern shifts again, now forming a continuous loop between their suits. Blue energy flows to craft interface module, dispersing harmlessly across their protective gear. Superconductivity dims slightly, becoming less chaotic and more defined. It is calming down. You cautiously extend a hand. Your suit glows brighter at contact points, absorbing excess thermal energy. Where flames touch you, they do not burn but rather flow as liquid light across surface. Your suit absorbs energy, channels forming across its surface that were not there before. It is rewriting my molecular structure, upgrading it. Alana's hand glows with concentrated thermal radiation. You watch as her suit continues to transform, developing intricate patterns that match superconducting energy signature. Her suit now features intricate thermal exchange circuits that pulse with its energy. Flames part around her hand, responsive to her touch. Superconductivity creates perfect thermal envelope because temperature regulation is its natural function. Elana emerges by harnessing fusion through nanotechnology. Combination of magnetic fields and plasma manipulation achieves fusion. Elana miniaturizes components while maintaining magnetically confined plasma stability. She explores innovative magnetic field configurations to confine plasma within smaller volumes. Her design includes a central fusion reactor core, plasma-facing components, and fuel injection system. Fission is a reaction where nucleus of an atom splits into smaller nuclei. A nuclear bomb, 100 generations of chain reactions occur per microsecond. Craft are implosion nuclear devices undergoing tamper-fast neutron fission. Cloaked in a perpetual aura of searing flames, craft fission radiates intense heat. It is made of molten magma, with a rocky shell surrounding an incandescent core. Core's oscillations are dictated by fleeting interval between release of prompt neutron and its absorption or escape. Fissile oscillations from isothermal lattice elemental arrangement alter effective neutron path length and reactivity. Within fission's molten element 92-235 core, thermal neutrons approach element 92-235. Nucleus captures incoming neutron through increasing reactions. Newly formed element 92-236 nucleus exists only for 10 to the 14th seconds in an excited state. Its nuclear binding energy destabilized by additional neutron. Nucleus forms when surface tension fights against electromagnetic repulsion until electrostatic barrier collapses. Every fissile movement releases cascades of neutrons and gamma rays, setting off chain reactions in ambient matter. You use thermal acoustic dynamics to absorb, deflect, and redirect chain reactions, but fission unleashes tamper-induced fast neutron bursts. Fission is a reaction where nucleus of an atom splits into smaller nuclei. Hundreds of generations of chain reaction occur in a microsecond. We have to slow it down for a moment for optimal flow. I can delay neutron fraction. Hold on. Delayed neutron fraction becomes critical for control. Neutrons lag behind prompt burst, creating resonant coupling between successive reaction generations to spawn periodic excursions. Slowing fast neutrons to thermal speeds, while also fluctuating in density due to localized heating, creates neutron diffusion oscillations, culminating in re-entrant criticality zones, where transient supercriticality gives way to subcritical dampening before rebounding. Ablation is generating breakdown plasma across forward sections. Surface temperature is reaching 4,000 degrees. Whole material is transitioning directly from solid to plasma state. You watch through reinforced viewports as ablation process unfolds. Craft's hull does not melt, but rather explodes into rapidly expanding plasma clouds that dissipate into space. Each impact site creates a miniature stellar explosion as solid matter transforms instantly into ionized gas. Breakdown plasma is expanding, so we are losing hull mass every second. Ablative shielding is doing its job, but it will not sustain this heat flux much longer. Ablation is protective and destructive. When heat hits hull, surface material absorbs thermal energy and vaporizes explosively. Plasma expansion carries away heat, protecting underlying structure, but each ablation event removes hull material. Ablation adapts craft for operation within harsh environment of breakdown plasma. Plasma emissions surround craft. Plasma interference blinds sensors through adverse light conditions. Craft has complete spherical vision coverage from detecting thermal signatures and electric magnetic fields. It captures sounds from all directions by detecting acoustic waves propagating through plasma medium. Ablation moves through breakdown plasma. Rapidly expanding, dissipating plasma clouds enhance its movement. Pressure waves from ablation events use explosive plasma expansion for propulsion. You warn Elana as temperature rises. Plasma will break down molecular structure. Ablation uses thermal energy to transform whole into plasma. Plasma field intensifies. It's filled with ablation zones that are regions where matter cannot exist in solid form, where everything becomes breakdown plasma that rapidly expands and dissipates. Black hole horizons represent ultimate ablation boundary. Beyond that event horizon, ablation becomes so intense that even plasma cannot exist, only breakdown of space-time itself. Ablation is gravitational destruction zones where matter itself breaks down. Craft navigates between regions where matter can exist in zones where everything dissolves into rapidly expanding plasma. Elana develops materials that withstand high temperatures and radiation inside tokamaks. Composites ensure components' durability. Metamaterials are multiple unit cells whose exact shape, geometry, size, orientation, and arrangement macroscopically affect light by creating resonances for permittivity and permeability. Acoustic metamaterials allow phase engineering on impinging sound waves. Metamaterials precisely control path of incoming gamma rays. Lens is adaptive, changing its properties in response to different radiation levels. Sheath is layer in plasma that has a greater density of positive ions. Magnetohydrodynamic focusing improves sheath flow. Phase change-coded sheaths encompass craft upon re-entry. Plasma pulses are controlled when Elana monitors sheath flow dynamics. Magnetic field lines guide ionized gas in perfect laminar streams, each flux line carrying current density. She watches plasma interface where charged particles meet containment wall. Beautiful sheath flow. Magnetohydrodynamic focusing is keeping boundary layers stable. Sheath region represents critical interface between bulk plasma and solid surfaces, as a thin boundary layer where plasma density drops exponentially as the electric field builds, containing charged particles. In this region, magnetic field lines compress and focus magnetohydrodynamic flow. Concentrated field lines become visible through intense plasma emission. Understanding how magnetic fields compress and guide plasma enables craft to follow along electromagnetic waves. Sheath stabilizes magnetohydrodynamic forces for balance. Plasma streams support sheaths through magnetic pressure, while focused field lines guide motion through electromagnetic topology. Sheath region is where different phases meet. Here, magnetohydrodynamic forces are strongest from being intensely focused. Different flux lines carry varying current densities. Focusing breaks down as uncontrolled flow takes over. Orderly sheath flow becomes chaotic as magnetic field lines tangle and reconnect. Each flux line carries varying current densities. Laser propulsion magnetohydrodynamic slipstream accelerators enable efficient atmospheric ascent. Sheath plasma surface interactions control plasma flows as thin boundary layers where plasma transitions to a solid surface or another plasma region. Sheath arises due to imbalance between lighter, faster electrons and heavier ions. Positive ion-rich layer balanced by a negative surface charge. Length defines thickness of sheath, where electric field shields plasma from surface charges. You harness tokamak edge turbulence to contain growing energy. It tends towards isotropy upon reaching reactor boundaries, culminating in uniformly stabilized force. Turbulence forms barrier to hold energy in check. In turbulence, plasma stirs at a scale larger than particle mean free path, causing fluctuations and turbulent cascades to develop that non-linearly transfer fluctuation energy to smaller scales. Turbulence navigates chaotic currents using plasma flows. Gyrating ion beams revolve around a fixed point in a spiral. You are caught up spinning an inexorable pull of gyration field. Your body's... It is trying to adhere us. We have to avoid becoming part of craft machinery. Where can we go that it cannot reach? Osmotic actuator is too delicate to be interfered with by nanotips. If osmotic actuators fail to regulate ion gradients, localized overpressure leads to enzyme denaturation. Osmotic pressure opening nanometer pores allows materials to flow out of cell, preventing cell damage. You and Elana burst through chamber door. Behind you, corridor rides with nanotips, but they stop at threshold, unable to penetrate delicate osmotic field. Osmotic actuator drops into floor, leaving element 1 to the 2-16 before it, as it pops up elsewhere, far away from nanotips. Nanotips writhe in confusion, unable to adapt to a system that can relocate itself at the molecular level. Translucent walls reveal glowing osmotic actuators. Spherical layers of molecules create a complex filtration system with nanometer pores opening and closing in rhythmic patterns. Elana manipulates tokamak structures and atoms on nanoscale. Sheets of advanced alloys float in microgravity. Materials are barely thicker than atomic layers, yet composed of precisely arranged atoms that give them incredible strength and flexibility. Continuum manipulator controls craft parts. In microgravity, craft takes form as continuum manipulators place parts for optimal plasma flow. It flies around, moving parts about, never stopping working. It continuously optimizes every atom, every field, every quantum state within craft. Craft becomes more perfect with each passing moment, approaching theoretical limits of performance and efficiency. You demonstrate how to construct plasma chambers. Manipulators begin weaving chamber walls atom by atom. Material is not just assembled, it is architected. Each atomic layer serves multiple functions: structural support, magnetic field generation, and plasma interaction control. Continuum manipulators arching and folding layered alloys as origami in zero pressure tension. They create structures that exist partially in normal space and partially in folded dimensions. Origami alloys become architectural elements. They create folds that exist, creating structures with impossible properties, materials that are simultaneously strong and flexible, conductive and insulating. Junction diode systems activate to create thermal barriers between molten rock and biological systems. It creates wide phonon bandgap, which suppresses phonon-electron coupling to prevent thermal runaway. Phononic salvation in frequency ranges where no vibrational modes propagate. Multimodal superinsulator forged for edge of thermodynamic collapse. It embodies final threshold between life's continuity and annihilation by unconfined energy. Junction diode excitations are confined so electric current stops flowing. Outermost regions in magnetically formed plasma edge are extremely well insulated. Vacuum edge transport through superinsulation habitability confines cytoplasm. Junction diodes protect life. She uses quark gluon plasma as spallation shield by creating a layer around craft that absorbs and disperses particulates. Interstellar propagation is not just a passive drift. It is a directed, intentional phenomenon dictated by the laws of thermodynamics, radiation shielding, tokamak turbulence, and gravitational wave amplification. Particle accelerators and magnetic confinement stabilize quark gluon plasma layer. Spallation shield protects against cosmic rays and space debris. She notes magnetic shielding and thermal insulation, creating a detailed architectural plan. Junction diodes insulate while spallation shield deflects to maintain life in its aboriginal state. You refine your spallation shields. 10 to the 15th electron volt protons are slamming into craft at near light speed, each impact threatening to cascade through systems in destructive particle showers. Cosmic ray flux is off charts. We are taking direct hits from galactic cosmic radiation. Particle energies are so high they are penetrating our shielding and creating secondary particle cascades inside craft. Elana monitors spallation detector arrays, which are instruments designed to measure how incoming high-energy particles break apart when they hit nuclei in craft's hull. Each collision creates a cascade of smaller fragments: protons, neutrons, pions, muons, and dozens of other particles spraying in all directions. Spallation reactions are producing neutron floods. Every cosmic ray hit is breaking apart atomic nuclei in our whole material, transforming single high-energy particles into cascades of hundreds of smaller fragments. When 10 to the 15th electron volt cosmic ray proton hits an element 16 nucleus in craft's hull, it does not just bounce off, it shatters nucleus with relentless and destructive force. Spallation injects neutrons, protons, alpha particles, and nuclear fragments with energies in the mega-electron to giga-electron volt range. Craft has a multi-layered shield system. Outermost layer is comprised of dense nuclear material with composites designed for maximum spallation cross-section. When cosmic rays hit this layer, they shatter into cascades of smaller particles exactly as intended. Look at that shield construction. Multiple layers, each one optimized for different particle energies. Outer layer handles giga-electron volt cosmic rays, middle layer catches mega-electron volt secondaries, and the inner layer absorbs fragments. Heat keeps shield materials in optimal crystalline states for maximum spallation efficiency. It glows brighter as it absorbs energy from particle impacts. They are energy distribution channels that spread absorbed radiation across shield surface to prevent localized overheating and structural damage. Spallation demonstrates its neutralization process as a massive cosmic ray burst approaches. 10 to the 16th electron volt particle shower would normally overwhelm any conventional shielding. Cosmic rays hit outermost shield layer with devastating force, but instead of penetrating through, they undergo controlled spallation reaction. Each cosmic ray proton shatters into dozens of lower energy particles that spread across shield surface area. Craft soars through turbulent atmosphere, cutting through clouds of ash and thermal updrafts. Lava planet's surface stretches below in orange fissures, crisscrossing black obsidian plains. Superconducting craft banks sharply around a massive volcanic plume, heat so intense it would vaporize conventional craft. Superconductivity absorbs excess thermal energy, growing briefly more brilliant before stabilizing again. Higher! Show us what you can really do! Craft responds instantly to her thought, angling upward in a steep climb. Craft accelerates, breaking through upper atmospheric boundary. Below, lava planet becomes a sphere of orange and black. As craft rises higher, planet's curvature becomes visible. Thin atmosphere's fragile shells surrounding volatile surface. Space opens into endless, beautiful, star-strewn expanse. Superconductivity flames do not diminish in vacuum. They grow more defined, more controlled, shifting from chaotic fire into structured plasma. So, atmospheric disruptions, volcanic activity. It is trying to generate enough heat to achieve escape velocity. It is trapped there when its dimensional tunnel collapsed. Everything it did is an attempt to go home. Inside void, encompassed by plasma. Craft banks gracefully by manipulating stellar winds and magnetic currents. Volcanic activity that had been threatening to tear a planet apart is now subsiding, fissures closing, pressure venting safely. Stars streak past as it soars, leaving volatile lava planet behind. Magneto-hydrodynamic craft drifts silently in abyss of space, its metallic hull faintly glowing from electrical storms surging within. It is a living system, a delicate interplay of physics and biology. At its heart pulses an array of enzymes, engineered life forms smaller than a nanometer. They are mission architects, couriers of life's essence, designed for ultimate challenge to seed neutron star crust with the spark of existence. Journeys perilous. In interstellar voids, lightning storms writhe. Craft harnesses this energy, drawing it into magneto-hydrodynamic chambers. Energy ripples outward as a controlled cascade designed to propel enzymes toward neutron star's surface. This singularity discharge is moment when life leaps into void. I have never seen anything like that. How you manipulate our electromagnetic fields? Your control over magnetohydrodynamic forces is incredible. I mean, you literally stabilized our flux rate with just a touch. Elana pulls out her technical instruments. Bremsstrahlung containment uses a nested field configuration. Field density is 3 times more stable than previous best configuration. Look at that magnetohydrodynamic light craft flux. Pulse cavity improves craft Bremsstrahlung containment and magnetohydrodynamic flux rate. Craft soars upwards from gravity well through acoustic resonance. Acoustic waves interact with space-time curvature. Harmonic series creates standing wave patterns in gravitational fields. Pressure differentials push against gravitational gradient. Higher frequencies become more effective as gravitational field weakens. Fission halts for a brief moment, contaminating neutrons. Scission is breaking of a chemical bond resulting in 2 smaller chains. You are taken aback by neutron poison's emergence. Neutron poison materials have a large capacity for absorbing neutrons. Metastable nuclear isomers in trapped neutron poison calculate specific time intervals of reactor operation 2 billion years later. 30 minutes of criticality, 2-hour cooldown. Neutron poison appears and defies chain reaction process. It's composed of isotopes with enormous neutron absorption cross-sections. It removes neutrons from chain reactions without leading to fission. Particles hide behind neutron poison's shield to survive fission's overwhelming escalation. Absorption cross-section dominates over fission cross-section. Neutron poison intercepts neutron flood. For every neutron absorbed, chain reaction loses a multiplication opportunity. Absorbed neutron flux is surrounded by electromagnetic barrier. Billions of neutrons capture events occur every second, each one terminating a potential chain reaction path. Craft contains nuclei in metastable states that remain stable for geological epochs. Neutron absorption events occurring in microseconds produce metastable nuclei that affect reactor operation billions of years in the future. Plasma follows a long path carved by neutron poison. Plasma does not flow properly, so tokamaks are disrupted. Quench is a termination of confined plasma. It is thermal runaway, causing magnetic shutdown. Quench disrupts tokamak gyrations from undulating plasma flow within reactors. By manipulating undulating flow, it destabilizes magnetic confinement needed for sustained fusion reactions. This disruption leads to operational issues, including potential shutdown of reactor and catastrophic failure. It influences plasma currents, creating turbulence and instability. It cannot take this path, but neutron poison said it has to. Quench is too dangerous. It will compromise craft. What can we do to keep it on the path while avoiding quench? Quench feeds on turbulence, on chaotic plasma disruption. We create a perfectly smooth laminar flow, an ordered plasma stream. Tokamak is out of order and will not restart. Craft is stuck. Defunct causes decay and ruin of tokamak reactors. Defunct is a patchwork of shattered magnets and flickering energy fields. Dying embers reflect remnants of failed fusion dreams. Drifting through shadow, cloaked in dark plasma, flickering as a starless constellation in motion. Craft was your companion, an omen of protection in deep radiation storms. It navigates gamma-ray corridors. It soothes magnetic anomalies. It whispers waveforms when no one else can. But now? Now it stands perfectly still amid roiling ground, as if time moves around it. Quench unleashes shockwaves until Craft crashes into molten crust. Wrecked Craft has recombinant matrix to seed life in symbiogenesis attempts. It draws upon every enzymatic pattern, every adaptive codon sequence encoded into substrate. Symbiogenesis substrate, once destined to bloom into survival architecture, is now a fuel reservoir. Fractured Craft hurtles through saturated nebula, its core erupting in ultraviolet flares as space bleeds light. Craft's nuclear scaffolding crackles with leftover reactor current, drawing in every fragment of computational biomass. Enzyme and substrate containers are kept in stasis until moment of impact. Life seeds deep cryovolcanoes beholden to thermodynamic consequences. Craft is terminally colliding to end flight. It dismantles Craft, breaching its hull, tearing apart spallation fields, crushing nanowires. It generates shockwaves to destabilize Craft. Magnetohydrodynamic Craft roll as wheels, maneuvering within fissures upon impact. Craft propulsion systems activate for rolling to reposition within fissures. Its magnetohydrodynamic field adjusts continuously, creating perfect traction against irregular surfaces. Craft rolls with mechanical precision, harnessing electromagnetic harmonics. It digs deeper than any normal root system could reach, penetrating through clay and rock to find fertile layers beneath. Roots spread in all directions, creating a vast underground network in moments. Craft goes deeper. It navigates tight spaces in irregular terrain, easily rolling down entirety of mountains and sinking into deepest volcanic chambers. Craft begins controlled roll down volcanic slope. Its electromagnetic field creates perfect traction against rough basalt surface. Craft accelerates smoothly, rolling faster and faster as it follows mountains' natural contours. It spirals along walls. Craft uses differences in magma density to guide its descent. It rolls along boundaries between different types of molten rock, following densest flows towards deepest chambers. Rolling motion creates drilling effect that opens new passages, always seeking next chamber, deeper depth, next space to navigate. It spins up to maximum velocity. Craft's magnetic field redistributes, concentrating energy into rolling interface. Plasma jets fire in precise microsecond bursts, creating continuous forward momentum. Seep deep into core where lightning triggers anticodon to catalyze, engaging replication and subsequent metabolism seeking homeostasis. Lava turns to luscious fields. Continuum manipulators nano-weld pulse cavity in osmotic actuation alignment. Junction diodes insulate while spallation shield deflects to maintain life in its aboriginal state. Flow is isotropic, beams are aligned, fluid is ideal. Craft responds perfectly to stellar cycle. Plasma into funnels, cyclotrons whirl, synchrotrons beam, tokamaks pulse, Ds oscillate. Flow is superconducting, Craft flies nominally. Craft barely holds together. Plasmaspheric hiss causes acoustics to go in and out of resonance. Supermirror and master oscillator compensate. Metamaterials comprising sheets stay perfect. Craft reaches hypernebula destination through habitable entrances. Spectrometer, magnetometer, interferometer guide Craft exactly where it needs to be, immediately behind hypernova. Hypernova guides Craft ahead. Turbulence causes Craft spin out by off-centered fission, generating neutron poison that causes quench. Ablation causes nanowires attached by cantilevers with nanotips to deconfine. Craft falls into closing neutron star crust. You crash, Craft, and roll until you and local dispersal clouds seep deep into fissure. Quench fights crash and vacuum is lost on impact.